if I'm talking about 3 moles of hydrogen at 1 bar, 100 degrees Celsius, I'm not going to write given 3 moles of hydrogen at 1 bar and 3 degrees, blah, 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 right? I'm going to write it in a compact notation. I'm going to write it like this. 3 moles of hydrogen, which is a gas, at 1 bar, 100 degrees Celsius. Okay? This notation gives you everything you need to know about the system. It tells you the number of moles, tells you the phase, tells you what kind of molecule it is, and gives you 2 variables that are state variables. You could have the volume and the temperature. You could have the volume and the pressure. But this tells you everything. Okay? I don't need to write it out in words. Right? And then if I want to tell you about a change of state, or let's first start with a mixture. Suppose that I want to that I give you a mixture, like this is a homogeneous system with 2 components, like 5 moles of H2O, which is a liquid at 1 bar, 25 degrees Celsius, plus 5 moles of CH3CH2OH, which is a liquid at 1 bar, 25 degrees Celsius. Okay, this describes roughly something that is fairly commonplace. It's 100 proof vodka, right? Half water, half ethanol. That describes that macroscopic system. Okay? You're missing out the impurities, all the flavor molecules that go into it. Right? But basically, that's the homogeneous system here you described. 2-component homogeneous system. Then you can do all sorts of predictive stuff with that system. All right, that's the equilibrium system. Now we want to show a notation. How do we go from one equilibrium state, like this describes, to another equilibrium state? So we take our 2 equilibrium states and we just put an equal sign between them. And the equal sign means go from one to the other. So if we took 3 moles of hydrogen, which is a gas at 5 bar and 100 degrees Celsius, and which is a nice equilibrium state here, and we say, all right, now we're going to change the equilibrium state to something new. We're going to do an expansion, let's say. All right? We're going to drop the pressure. The volume is going to go up. I don't need to tell you the volume here because you've got enough information to calculate the volume. The number of moles stays the same. Closed system. Gas doesn't come out. It stays a gas, but now the pressure is less. The temperature is less. I've done some sort of expansion on this. I've gone from one equilibrium state to another equilibrium. And the equal sign means you go from this state to that state. It's not a chemical reaction, right? That's why we don't have an arrow here. Because we could go back this way, too. We can go back and forth between these 2 equilibrium states. They're connected. This means they're connected.